Welcome to the deep dive. Today we're digging into something pretty complex, but really interesting. How a financial institution, dealing with all those strict data rules, can actually leverage cloud computing. Specifically, we're looking at a mix of Google Cloud Platform, GCP, and their own on-premises gear. We've got a detailed plan of this setup, and the goal today, unpack the strategy behind it all. Think of this as your shortcut to understanding how they balance regulation and, well, cloud innovation without drowning in tech jargon.
Exactly. We're looking beyond just the technical bits. We want to understand the why. Why keep certain things in-house? Why move others to GCP? And crucially, how do you securely connect them? Manage who gets access. Keep an eye on everything. It's really about using smart tech to navigate some very tricky regulatory waters.
Okay, let's jump right in then. How do they decide what stays put and what moves to the cloud? The source material points to a few main drivers: rules, performance needs, and, just the reality of older systems they still rely on.
That's spot on. For a bank, some things just have to stay on their own iron. Take their core banking systems. That's the absolute heart. Primary ledgers, transaction processing, KYC checks, and those critical credit scoring algorithms. That stuff often involves really sensitive data, PII, directly tied to money. It's heavily regulated, so keeping it on-prem is often the only way to meet strict data residency rules.
Right, so it's not just about the core transactions. It sounds like whole categories of data are locked down by geography, like primary customer data that literally can't leave a specific country, or systems governed by local banking laws, maybe even market-specific trading rules. It sounds like a real maze of regulations that makes going pure cloud, well, difficult.
It is, and what's interesting is the level of granularity needed. It's not just customer data stays here. It's about knowing the exact legal lines, which countries might restrict cloud use entirely for certain data types. These aren't abstract points. They dictate the physical location of infrastructure.
And then there's the tech they already have, right? The source mentions mainframes, which are still around. Specialized hardware like HSMs, those secure key vaults and applications that are just deeply tied into their local setup. Moving those sounds like a nightmare. Plus, some things just need near-instant response times where latency really matters.
Exactly right. Sometimes the tech constraints are just as real as the regulations. You can't just easily migrate something off a mainframe it was built for, or get rid of hardware needed for specific security certs, like FIPS compliance with those HSMs. These are practical, real-world factors shaping their hybrid plan.
Okay, so with all that staying in-house, what is a good candidate for GCP? Seems like it shifts towards customer interaction, data analysis, internal business tools, and speeding up development.
Precisely. The cloud often becomes the place for customer engagement and faster innovation. Think about their online banking portals, their mobile apps. The key thing here, and the source highlights this, is how they handled the data. Techniques like data tokenization, where sensitive data points get swapped for non-sensitive tokens, or pseudonymization, which makes data less directly identifiable. That lets them build modern front ends in the cloud without putting that core sensitive data directly out there.
Ah, so that's how they manage it. The app the customer uses might be in the cloud, scalable and smooth, but the actual sensitive account data it works with stays secure back on premises.
Exactly. The cloud acts as an interaction layer, but the regulated data stays put. And it's a similar idea for analytics and BI. They might use anonymized data with all personal identifiers stripped out, or tokenized data in cloud data lakes. Then they can run ML models, maybe for fraud detection using this less sensitive data, or generate BI reports from aggregated financial info. The goal is insights without needing direct PII access in the cloud.
That makes sense. Getting the analytical power without the high-stakes data risk. What about internal business apps, HR systems, planning tools? They seem lower risk.
Generally, yes. Things like HR, internal collaboration platforms, knowledge management, they usually don't handle the same kind of heavily regulated financial customer data. Moving those to the cloud can bring efficiency gains, free up on-prem resources, make scaling easier. The source mentions document management in the cloud too, but adds that important qualifier with appropriate data classification. So even internal stuff needs careful handling.
And the last big area mentioned was development and testing. Sounds like a big win for agility there.
Oh, absolutely. Being able to spin up and tear down dev environments quickly using infrastructure as code. Running automated CI/CD pipelines for faster releases, testing with synthetic or anonymized data. It really boosts innovation and can cut costs. Cloud sandboxes give developers safe places to experiment without touching live systems or sensitive data.
Okay, so we have these two environments, on-prem and GCP. They obviously need to talk to each other reliably and securely. The connectivity architecture in our source sounds pretty serious. No cutting corners here.
Definitely not. Robust connectivity is non-negotiable. Their main link is dedicated interconnect. We're talking dual 10 Gbps connections, physically separate paths, creating a resilient metro ring
Yeah.
that comes with a high SLA 99.99% uptime and uses MASIC encryption right at the network layer. Very secure, very high performance. It's not just your standard internet link.
Tool 10 gig links. Wow. And backups. What if something happens to those main lines?
Yep, they've got high availability VPNs and also Partner Interconnect as backup routes. It's all designed for automatic failover. If that primary dedicated interconnect has a wobble, traffic should switch over seamlessly.
Got it. And it's not just about having the pipe, but directing the traffic efficiently. Cloud Router with BGP is mentioned for path optimization. What does that do in simple terms?
Think of Cloud Router like an intelligent air traffic controller for their network data. It uses BGP, a standard internet routing protocol, to constantly figure out the best path for data between their sites and GCP. They can also tweak these routes, maybe prioritize critical traffic using QS markings. It keeps things flowing smoothly.
Makes sense. Now, security across this connection must be huge. What kind of network defenses are in place?
It's really a layered approach, defense in depth. At the edge, you'd see things like Cloud Armor for DDoS and web attack protection, next-gen firewalls inspecting traffic coming in and out, intrusion detection and prevention systems, maybe data loss prevention scanning to catch sensitive data trying to leave, and API gateways to secure how applications talk to each other.
So locking down the perimeter, but also controlling traffic inside the network.
Exactly. Segmentation is key. Using shared VPC to carve up their cloud environment, maybe microsegmentation to control app-to-app communication very granularly, security groups, network tags for applying policies dynamically, and VPC service controls are crucial. They create a strong boundary around GCP resources to stop data exfiltration. They even look at inspecting east-west traffic, the communication happening between services within their hybrid setup.
And things like DNS, making sure systems can find each other. That sounds like plumbing, but critical plumbing.
Absolutely critical. Cloud DNS with a split horizon setup lets them manage internal and external name resolution differently. Conditional forwarding helps systems find resources across the on-prem cloud divide. Private zones keep internal service names off the public internet. Automation keeps it all synced up. And service discovery tools help applications find each other dynamically.
How do services talk securely across this hybrid setup without going over the public internet? The source mentions service networking.
Right, that's where things like Private Service Access and Private Service Connect come in. They let their internal systems reach Google APIs and manage services privately and securely. Service Directory acts as a central phone book for all their services, and using things like gRPC with mutual TLS ensures encrypted, authenticated communication between apps. Internal load balancers help distribute traffic reliably too.
Okay, and APIs are everywhere now. How do they manage those consistently across both worlds?
Apigee API management is mentioned. It can span both on-prem and GCP. This gives them one place to manage security policies, monitor usage, apply rate limiting, handle versioning basically, consistent governance for all their APIs wherever they run.
All right, let's shift gears to people and applications, identity and access management. This sounds like it could get really messy in a hybrid scenario.
It really can. That's why getting the foundation right is so important. Job one is integrating their existing identity system, probably Active Directory, maybe using ADFS with GCP. They use standard protocols like SAML or OIDC for that federation, map user attributes across, maybe use just-in-time provisioning, and multi-factor authentication, MFA, is absolutely table stakes everywhere.
So they're extending their existing identity store, not building a whole new one in the cloud.
Ideally, yes. Tools like Google Cloud Directory Sync help keep user accounts and groups consistent between, say, their on-prem AD and GCP. They can configure it carefully, maybe selective sync, often one-way sync so AD stays the source of truth. Automated checks help catch any drift.
What about the high privilege accounts, admins and such? How do they lock those down?
Yeah, Privileged Access Management, or PAM, is crucial. That means having break glass processes for emergencies, just-in-time access, so privileges are granted only when needed and for short periods, session recording for audits, separate admin accounts with tighter controls, and within GCP, Cloud IAM lets them define very granular custom roles.
The security thinking sounds very much like zero trust, never trust, always verify.
That's definitely the goal. Implementing something like Beyond Corp Enterprise means access isn't just about who you are, but also the health and state of your device. It involves continuous authorization checks, risk-based authentication, stepping up verification if needed, and using identity-aware proxies. Access isn't granted just once.
And managing all those access rules consistently must be a challenge.
It is. That's why centralized policy management is key. You want consistent role-based access control, maybe attribute-based access control, across both environments if possible. Central administration points, automated deployment and validation of policies, regular reviews driven by compliance needs, and of course, enforcing segregation of duties.
Okay, that's people. What about applications? How do they securely access resources?
That falls under service identity management. Things like workload identity and GKE give pods their own identity. You need strong governance around service accounts, using short-lived credentials instead of static keys where possible, maybe key restrictions. Service Identity Federation can also help bridge identities between systems securely.
And to really sensitive stuff, passwords, API keys, certificates, how are those handled?
You need a hybrid secrets management strategy. Google's Secret Manager for cloud secrets, definitely, but also integration with their on-prem HSMs, perhaps via Cloud HSM, for keys that must stay physically within their walls due to regulation. Plus, a solid plan for replicating secrets where needed, automated rotation to limit exposure time, and thorough audit logging of all access.
Wow. Okay. So much going on, so many moving parts. Seeing everything clearly monitoring and observability sounds absolutely vital.
It's fundamental. Without unified visibility across both on-prem and cloud, you're flying blind. You can't effectively operate, troubleshoot, or secure this kind of complex hybrid environment without seeing the whole picture.
So what does the monitoring setup look like? How do they get that unified view?
It starts with collecting telemetry, metrics, logs, traces from everywhere. Google Cloud Monitoring is the central platform in this case. They'd use collectors, maybe something like Bindplane, to pull data from their on-prem systems. Collecting custom application metrics, using agents or agentless methods, it needs a robust pipeline to handle all that data.
And all the logs generated by everything.
Centralizing those in cloud logging is key. On-prem forwarders securely send logs to the cloud. Using structured logging makes analysis much easier. Then they can route logs based on retention needs, and crucially, integrate with their SIEM for security analysis.
Distributed tracing, that sounds like following a single user request as it bounces between systems.
Exactly. Using standards like OpenTelemetry to instrument applications and then CloudTrace to visualize the journey, you can see how long each step takes, even if it crosses from cloud to on-prem and back. Correlation IDs tie it all together. Custom attributes can add business context, and sampling helps manage the volume.
Okay, they've collected all this data. How do they turn it into something useful for operations?
Unified dashboards are essential, showing key metrics from both worlds side by side. Maybe business service maps showing dependencies, tracking SLOs and SLIs for hybrid services, different views for different audiences, executives, ops teams, etc.
So it's about getting actionable insights, not just raw numbers, seeing the health of the whole system.
Precisely. The alerting needs to be intelligent too. Correlating related events across environments, routing alerts to the right teams, prioritizing based on business impact, maybe automated incident classification, and integration with tools like PagerDuty or their main ITSM system to manage the response.
Performance is always key. How do they track and optimize that in this mixed world?
Performance analytics tools help establish baselines, spot anomalies, analyze trends for capacity planning. Correlating technical metrics with user experience is vital, and tracking things like database query performance across the hybrid setup is often critical.
And how does all this monitoring feed into their overall security posture?
It's crucial. Security Command Center in GCP can provide a unified view of security findings. Event threat detection analyzes logs for suspicious patterns. Custom rules in their SIEM can look for threats spanning both environments. Behavioral analytics can spot unusual activity, scanning for indicators of compromise, and continuous compliance monitoring, checking for configuration drift, automating evidence gathering for audits, managing vulnerabilities across all assets.
That's a lot of focus on the infrastructure and applications. But the data itself, managing and governing that must be incredibly important in finance.
Oh, absolutely paramount. It really starts with understanding the data through a solid data classification framework, automating classification where possible, tagging data with metadata, tracking its lineage where it came from, where it goes, maintaining an inventory of sensitive data, and then enforcing policies based on that classification. You have to know what you have.
Know your data, know its sensitivity, know where it is. Makes sense.
Then you need strong controls around data movement. Preventing unauthorized exfiltration is key. Using DLP scanning, maybe tokenization or field-level encryption when data does need to move between approved locations. Perhaps even manual approval workflows for transferring highly sensitive data sets.
And what about managing data over its whole life?
Consistent data lifecycle management policies are needed across both worlds. Automated archiving, automated secure deletion based on retention schedules, processes for legal holds, handling privacy requests like under GDPR, and ensuring they have a defensible disposition process proof that data was properly destroyed when required.
Okay, last piece on data. Databases and storage.
Yeah.
How do they approach that in this hybrid model?
The database strategy often involves keeping primary transactional databases on-prem, as we discussed, due to regulations. But they might use read replicas in the cloud for things like reporting or analytics, kept in sync using change data capture, CDC. Database encryption is a must, maybe using customer-managed keys. Query federation tools might let them query across environments, but carefully. For storage, it's usually tiered. Cloud storage for less sensitive data, backups, archives, on-prem storage for the highly regulated stuff. A solid, geographically distributed backup strategy and compliant archive storage are critical components.
So pulling this all together, it's clear this isn't just a simple move some stuff to the cloud project. It requires a really structured approach.
Definitely. The migration methodology has to start with a detailed workload assessment, looking at data classification, regulations, application dependencies, technical fit, cost, risk for each workload. Then deciding on the right migration pattern, maybe just rehost it, lift and shift, maybe replatform it with some changes, maybe fully refactor it for the cloud, replace it, or consciously decide to retain it on-prem. And implementation has to be phased. Build the foundation first, migrate less critical things, then move in waves aligned with business priorities, constantly evaluating.
And once it's running, how do they actually operate this complex beast day to day?
A clear operational model is needed. A responsibility matrix, who owns what. Adopting SRE practices helps maintain reliability. Define processes for managing incidents that might span both environments. Consistent change management, proactive capacity planning.
And I'm guessing automation is the key to making any of this manageable at scale.
Absolutely critical. Automation and DevOps practices underpin the whole thing. Infrastructure as code, IAC for managing resources consistently everywhere. CI/CD pipelines targeting the right environment. Configuration management tools spanning both. Self-service portals for developers, but with guardrails. And automated testing, crucially including compliance checks built into the process.
Okay, let's try to summarize. What are the really core takeaways from this deep dive into this hybrid financial setup?
I think the biggest one is the strategic workload placement, driven primarily by data residency and regulation. Know what must stay on-prem. Second, the absolute necessity of robust, secure, and redundant connectivity between the two environments. It's the lifeline. Third, unifying identity management, extending existing systems, and embracing zero trust is critical for security and usability. And finally, you just can't manage this complexity without comprehensive, unified monitoring and observability across everything. You need that single pane of glass.
Yeah, and the aha moment for me is seeing how they bridge the gap. It's not that cloud is off limits for finance. It's that you need smart strategies, using tokenization, pseudonymization for data, leveraging specific compliance services like assured workloads in GCP, and building really strong governance and security around it all.
Exactly. It shows that with careful planning, understanding the rules deeply, and applying the right tech, even highly regulated industries can tap into cloud benefits like scalability and innovation. It's about being deliberate and risk-aware.
So looking ahead, regulations evolve, cloud security tech keeps getting better. What's next for these kinds of hybrid architectures in finance? Could they push more to the cloud eventually? What new challenges or maybe even opportunities might pop up? Makes you wonder how they'll continue to optimize this balance in the coming years. Lots to think about there. Thanks for exploring this with us today.